with Confluent, and he's going to give a lightning talk, 15 minutes, on performance testing Kafka Connect. Some very simple ground rules. Please keep your mobile on silent mode. Please keep questions in the end. And please download the app, rate the app for the session. It's absolutely important for the feedback because we want to make it better the next time. Thank you very much for attending this. Vikas, all yours.
Hello everyone, good afternoon. My name is Vikas Balani and I'm a software engineer at Confluent. Today I'll be talking about various aspects related to performance of connectors. Before we begin, just a quick introduction to Kafka Connect for those who haven't used it before. Kafka Connect is a technology that enables you to connect your external system to Kafka cluster without writing any new code. The components that are actually responsible for transferring the data are called connectors. The connectors which transfer the data from your source system into your Kafka topics are called source connectors. And the connectors which fetch the data from your Kafka topic and write them into the sink system are called sink connectors. In this presentation, I'll be talking about how you can optimize a Kafka Connect setup to get the maximum performance out of your connectors. Now, when we talk about performance, we are specifically interested in two key metrics, which are the throughput, that is the rate of transfer of records, and the resource utilization, which is the amount of resources consumed by the connector to enable that throughput. Now, how do we benchmark the performance of a connector? We do that by generating load on the connector and then evaluating its throughput and resource utilization. We refer to this whole process as performance testing of connector. Now let's see how we can set up a performance test. In order to do that, we first need to establish a data pipeline. The first component of this pipeline is the source or the sink system. This could be a MySQL server, an S3 bucket, or any external system that you wish to connect to your Kafka cluster. Next, we need to set up a Kafka cluster, and this could be on Confluent Platform, Confluent Cloud, on Amazon MSK, or you can even set up your own self-managed Apache Kafka cluster. Next, we need to set up a connect cluster and deploy the connector to connect the external system to the Kafka cluster. This completes our data pipeline. The next component we need to deploy is the load generator, which will generate records into our source system or Kafka topics. You can use HammerDB or JMeter to generate load into databases. And if you're trying to perf test a sink connector, then you can use the DataGen source connector to generate traffic on the Kafka topic. Lastly, we need to set up an observability service, which will collect the metrics from the connect cluster. Now, to run the performance test, we need to trigger the load generator, which will generate load into the source system and create stress on the source connector that we want to test. During the load generation, the connect cluster is emitting metrics, which are picked up by the observability service. After the load generation is completed, we are going to fetch these metrics from the observability service and assess the achieved throughput and resource utilization. Similarly, if you are trying to perf test a sink connector, then the setup will remain exactly the same, except that now your load generator will generate records into Kafka topics, and the flow of data in your data streaming pipeline will now be reversed. Now that we have established how we can perf test a connector, let's take a look at the effects of connector configurations on performance and how we can fine-tune these configurations to get the most out of our connectors. So this is what our tuning strategy should look like. We should only change one configuration at a time. Then we should perf test the connector with each of the different configurations. And finally, we should select the configuration which gives us the best performance. Let's take a look at an example where we leverage this tuning strategy. Suppose you're trying to configure an object store sink connector, like S3 sink connector, and you stumble across the flush.size configuration. This configuration allows you to configure the maximum number of records that the connector will write to a file before it flushes it to the object store. You wonder if this configuration can have any impact on performance, and if so, then what is the optimal value for your specific workload? To explore this idea, we can set up an experiment where we first perf test the connector with flush size set to 1,000, and then perf test it again with flush size set to 3,000. After running the test, this is what we find. With configuration A, that is with flush size of 1000, we get a throughput of 5.11K records per second. And with configuration B, we get a throughput of 13.1K records per second. With this data, it is clear that flushing larger file leads to a higher throughput. And this is a valuable insight that we can leverage to optimize connector performance. Now, let's jump into another example. Suppose you're trying to configure an S3 sync connector on a highly partitioned Kafka topic, and you notice that the connector is taking up a significant chunk of memory on the connect worker. To tackle this issue, you wonder if enabling the elastic buffer can help reduce the memory footprint of the connector, and if it has any impact on the performance. Before we delve into that, let's quickly recap the buffer options available for the S3 sync connector. So we have two types: the fixed buffer, where the connector allocates a buffer of fixed size for writing records, and the elastic buffer, which starts with a smaller memory allocation and doubles in size each time it reaches capacity. Now, to explore the performance difference between elastic buffer and fixed buffer, we can set up an experiment where we first perf test the connector with elastic buffer disabled, and then test it with elastic buffer enabled. After running the test, this is what we find. When employing the elastic buffer, there is no discernible impact on the throughput of the connector. The CPU utilization increases by 2% on average, from 67% to 69%. However, the memory utilization drops significantly from 8.4 GB down to just 4.75 GB. What we can take away from this data is that the use of elastic buffer can help reduce the memory footprint of S3 sync connector. Just a word of caution, though, that the use of elastic buffer with certain workloads can cause the connector to use very high CPU utilization, and that may result in dips in performance. So it is important that you test it with your own workload before enabling it for your connector. Now, besides connector configurations, there are a lot many external factors that can affect the performance of a connector. And to study the influence of these external factors, we employ a process called as chaos testing. Chaos is any unpredictable real-world event which can happen in a production setting, like network failure or pod failure, and the simulation of these chaos events in a controlled manner to study the behavior of the connector is what we refer to as chaos testing of Kafka connectors. Coming to the examples, first we have chaos scenarios where we gradually inject packet loss and jitter into the connect cluster. The first graph over here shows the throughput of the connector as we inject more and more packet loss into the cluster. Initially, the throughput lies at 19.2K records per second with 0% packet loss. When we inject 5% packet loss, the throughput drops to 16.3K records per second. And as we continue to increase the packet loss, the throughput keeps on decreasing. In case you're wondering, these red boxes demarcate the time window during which the chaos is not active. So during this period, there is no packet loss or injected jitter in the connect cluster. Similarly, with jitter, we see that the throughput starts at 19.2K records per second when there is no injected jitter, and the throughput keeps on going down as we continue to increase the jitter value. What we can learn from this data is any faults in the networking setup of connect cluster can have adverse effect on the performance of the connector. Another chaos scenario is when we have multiple connect workers, multiple connectors running on the same connect worker. And one of the connector ends up hogging all the CPU resources available on the connect worker. To simulate such a scenario, we gradually inject more and more CPU stress into the connect worker. The first graph over here shows the throughput of the connector, and the second graph shows the total CPU utilization on the connect worker. We observe that when the CPU utilization is less than 100%, the external CPU stress does not have much impact on the performance of the connector. But when the CPU utilization reaches 100%, the external CPU stress causes the throughput of the connector to decrease. Like we can see when the external CPU stress is 80% or 90%, the throughput drops to 13.5K records per second or 7.1K records per second. Now, in real-world scenarios, we do not usually encounter cases where the CPU utilization is constantly at 100%. Rather, we see spikes in CPU utilization which reach 100%. And these spikes leads to degradation in performance of all the connectors which are running on the connect worker. So it is crucial that to avoid this particular scenario, that we scale our cluster accordingly and ensure that all the tasks are distributed evenly. With this, I wrap up my presentation, and I leave you with these key takeaways. Thank you.
So if you have any questions, we have some microphones, and we can bring microphones over to your seat. Please raise your questions there so that others can hear, and Vikas can answer.
Hey, hi. This is Pradeep from Allstate, right? I just want to understand how does the different Java version impact the performance of the Connect worker nodes?
For that, we'll have to set up another experiment. That is something that we have not explored before. But we can use the setup which was described in this presentation to explore the scenario as well.
Hey, hi. So you are showing the CPU utilization, right?
Yes.
So this is Manish here. I think you are able to see me. So the CPU utilization, is it connector specific? So let's say we are using S3. Will it take more CPU? So the CPU utilization, is it connector specific? So let's say we are using S3. Will it take more CPU? So the CPU utilization, is it connector specific? So let's say we are using S3. Will it take more CPU? The CPU utilization, is it connector specific? So let's say we are using S3. Will it take more CPU?